Welcome to PGSMaths. This is a quick video requested by YouTube user Elite Boxhead in regards to upper and lower bounds. Now, bounds are used when we're talking about finding the maximum and minimum possible value that something could have been before it's been rounded. So if we look at the number 1 in the context of being rounded to the closest whole number, what's the smallest value this could have been? The smallest value that this could be has to lie somewhere between 0 and 1. Because at 0, any number that says 0 will be rounded to 0. 0.1 is still closer to 0. 0.2, 0.3, 0.4 would all be rounded to 0. But as soon as you hit 0.5 and are asked to round that to the closest whole number, that becomes rounded to 1. So this is our smallest value that could have been rounded to 1 as the closest whole number. So this is called our lower bound. It can also be called a limit, but don't get too confused with that, especially if you're thinking about doing A-level. So our lower bound for this question will be 0.5. So what's the maximum number that would have been rounded to 1? We call this value the upper bound. Again, as we continue up through decimals, 1.1 would still be rounded to 1, 1.2, 1.3, 1.4. But when we get to 1.5, which is halfway between 1 and our next whole number, we'd find that 1.5 is rounded up to 2. Anything bigger than 1.5 would be rounded to 2, but anything smaller than 1.5 would get rounded down to 1. Now the actual upper limit in this situation would be 1.4999999999999, etc., etc., etc. So it's safer to actually say that 1.5 would be your upper bound. So any number, any decimal, any value that lies between those two terms, 0.5 and 1.5, would all be rounded to give us 1. So in this situation, these are our upper and lower bounds. When rounding to a closest whole number, we can go half either way of that value to find out what its boundaries are. So what happens if we rounded to something different? Let's assume that we have the number 300 and it's been rounded to the closest 100. What's the smallest value this could have been? Well, it's definitely not 200. We have to once again go halfway between our value and the 100 below it. So that means that our lower bound this time would be 250. Our upper bound would be halfway between 300 and the next 100 along, which would give us an upper bound of 350. So what we should notice is that the lowest number is half of the distance that was rounded to, away from our original value. Half of what we rounded to, added on, becomes our upper bound. So if I had rounded a number to the closest 10, for example 70, how far either side of 70 would we have to go for our lower bound and our upper bound? Well, if we've rounded to 10, half of that is 5. So our lowest bound will be 70, take away 5, giving us 65. 65 is the smallest number that could possibly have been rounded to 70 if we're rounding to the closest 10. Same thing with the upper bound. The biggest number would be 75. So whatever your number has been rounded to, half it, and then you can add it and take it away from that original value here to find out what our two bounds are. This still works with decimals. So just to prove this, if we've rounded to 1 decimal place, we're going to half 0.1 because that's what we've been rounding to. Well, half of 0.1 is 0.05. So to find our lower bound, we're going to have to take that away from 3.3. So 3.3 subtract 0.05 will give us a lower bound of 3.25. If we round 3.25 to the closest 1 decimal place, we're going to get 3.3. So therefore anything above that up to 3.3 will give us 3.3 as our answer. So this still works. What would the upper bound be? It's going to be 3.3, and this time we're going to add on 0.05. Which gives us an answer of 3.35 as the highest possible number that could have been rounded to give us 3.3. Remembering it's actually 3.349999 recurring. To put this into a context, let's look at the kind of problem that comes across in exams. A lot of times they like to use weights, saying things have been rounded to the closest kilogram, to the closest 5 kilograms. So pay attention to what it's been rounded to, half it, half that distance, and add it and take it away to find out what your possible limits are. But on top of that, we also like to find out what's the biggest possible difference between numbers. So to find the biggest difference, we need to find out what the biggest value for B was and the smallest value for A could possibly be. Take into context what the question is asking for. You might need to do it the other way around sometimes. So in this context, we want to find the biggest difference in heights. Let's start off by finding the lower bound of boy A. Well, we've rounded to the nearest 10 centimeters, so for the lower boundary we take our value and we're going to take away a half of what it's been rounded to. So half of 10 centimeters is 5 centimeters. If these were in different units, if that had been given as 1.7 meters, we'd have to make sure we converted to the same units before doing this calculation. Either way, the lowest height this boy could have been is 165 centimeters. So the maximum height, or the upper bound of boy B would be 190 centimetres, which was what the measurement was given as, but it could have been up to 5 centimetres taller than that and still be given as 190 centimetres. So that gives 195 centimetres height. So to answer the question, the maximum difference would be 195 subtract 165, giving an answer of 30 centimetres. And that's how bounds are used.